Hi everyone, thanks for coming. Today, Yatin and I are going to give you guys a little talk about the process we went through when we were redesigning the new Google Maps, as I'm sure you saw on the keynote on Wednesday. Hope you guys are enjoying this. So my name's Jonah. I'm the lead designer on the new Google Maps.
And I'm Yatin. I'm the engineering director. I led the team that built the new Google Maps.
So as we were going through this process of doing this redesign from the ground up, as Bernie and I mentioned when we were on the stage on Wednesday, there were three main concepts, and we're going to do a deep dive on two of them today. Now, one of them was that we can build a new map with every click, and there are some quite interesting, difficult problems that we had to solve in order to do that. And another one is that we wanted to make sure that all of the imagery we have in the world is very easy to discover and fun and immersive as well. So we're going to go through those two. So on the first one, let's talk about how we build a map for every place. Now, one of the most important things in building this map for every place is highlighting and making sure that we're labeling the right roads. And this is actually quite a challenging thing to get right. So I'll tell you a little story first, which is that I like to travel a lot, and I think it's amazing that we've got these digital maps nowadays, and we can kind of carry these around in our pocket, and we can look at them on our computers and everything. But there's something missing a little bit from the old days of having an analog map. So this is an example of a map that was drawn for me when I first moved to Sydney a few years ago. And you probably remember when you were traveling, when you were a little bit younger, maybe when you went and stayed in a hotel, and the hotel concierge would draw you a map, and he'd kind of annotate on top of the existing map. So maybe they'd highlight some of the roads that you need to use to get to places that you're interested in. They'd kind of highlight places for you. And this map is great because it was a map that has been drawn for you and is unique to you. And it also is quite nice that it serves as a form of nostalgia afterwards. So after your trip is done, you can kind of take this out 1 year later and look back on it. And we were wondering how we can build a map that feels customized to you, but also fit for purpose and everything. So if we look at how Google Maps looks today, you can see that this is a fairly kind of reasonable plain map of this area. This is actually close to my house in London. And if we wanted to draw a map of how to get to this park in the middle here, the Pullins Gardens, you could imagine that most traditional maps would probably just stick a pin inside the map and be done with it. But that probably isn't the best map that we could possibly draw for this place. Like, for a start, the two cross streets that you see right next to the Pullins Gardens, they're not even labeled, and that's perfectly reasonable. These are very small streets, and in the general scheme of things, these are not the most important roads to label here. But in the context of the Pullins Gardens, these are super important. And you can also see that there's just a lot of information. So even if we were labeling those streets, no attention would be drawn to those streets as being particularly important amongst all of the other streets that we've got nearby. Now, if we were to take a different approach, my wife actually just drew this map on a napkin, and you can see here that this is a vastly simplified representation of how to get to the Pullins Gardens in the middle here. Now, this might be a little bit hard for you to read our handwriting, so let me simplify this a little bit for you here. This is my kind of diagrammatic representation of the information that we were showing on the Pullins Gardens map here. Now, we've got several things we've left out and several things we've left in here. So the first is the major highways that are the major thoroughfares of the city are left in, because these roads are going to always be important because they're kind of context and part of the overall structure of the city. But the other thing we did was we drew Penton Place, Amelia Street, Crampton Street, Iliff Yard, all of these more minor streets that you need to take to get to the Pullins Gardens from the major streets. We made sure that those were highlighted and labeled as well. And of course, we also there's only one point of interest that's really important for this one, which is Kennington Station. This is the local subway station that you'd need to get there. But you could imagine that if there's other major landmarks nearby, perhaps where you're going to be turning off the streets, they would be an important thing to show as well. So again, here's the map that we had before. And now here's the map that we draw in the new Google Maps. Now, this isn't quite such a startlingly different change as you might first think, because you might think, oh, why didn't they just draw the equivalent of this napkin map? But actually, that's not exactly what we want in a new modern interactive map, because Maybe you miss your turning and you still need to be able to know what the other roads are nearby for context. Or maybe you're going to drag the map away or zoom in or zoom out. So we still need a map that's going to be useful in the general case, but we're going to subtly highlight all of these roads that are important and make sure they're labeled as well. So I'm going to hand you over to Yatin to explain how we did this process of selecting the right roads, because although it's maybe quite easy for one person to draw a local road for their local area, you can imagine that it's quite challenging to do this for absolutely any place in the world. So I'll hand you over.
Thank you, Jonah. So how do we go from this map, which is a very simple base map with a marker stuck on it for Pullen's Gardens? This is what you normally see in the classic Google Maps. How do you go from here to the map that Jonah just showed moments ago? Well, for starters, Google has access to a significant amount of anonymized information about how our users, our millions upon millions of users, use Google Maps every single day. We can analyze all of this information and use that to extract signals that allow us to figure out which roads to highlight on this map for this particular location. And we can do that over and over again every time a user looks at a map. So let's look a little bit more. What information can we use in order to figure out which roads are important for Pullen's Gardens? What I've shown here is every single driving directions that any user in Google has ever made to the general vicinity of Pullen's Gardens. So we look across all of our driving directions that users do millions of times every single day and figure out which of those driving directions are leading to the general vicinity of Pullen's Gardens and create a map that looks somewhat like this. Now, obviously, this is a lot of data. If I use this to highlight every single road that this map is showing in blue, that's not really going to give me any more compelling of a map than what we had before. So what do we do next? Well, we can look at each one of these driving directions and start aggregating them to figure out which little bit of road segment, how popular it is, and how many of our users are going to use it to get to Pullen's Gardens. So you can, again, analyze all of those driving directions. For every road segment that leads from one intersection to the next intersection, you can figure out how many of those driving directions would have used that particular road segment to get to Pullen's Gardens. And once you do that, you can rank all of the roads based on the popularity that they have for getting to the location that you want to highlight. And that's what this version of the map is showing. The deep blue roads are the ones that were marked as more important, more relevant for getting to Pullen's Gardens. The light blue ones are all of the other roads that we had in the previous slide. So you're now starting to see a little bit of structure to the map. I'm just going to take away all of the light blue so we can see this a little bit more clearly. At this zoom level, this now starts to look like a relatively clean and useful map for Pullen's Gardens. It's starting to look very similar to those napkin sketches that Jonah was showing earlier. Let's zoom in a little bit more and see what that looks like at a closer zoom level. So here's what that same data looks like as you zoom in to be able to sort of see the general neighborhood around Pullen's Gardens. And notice that those important roads are still highlighted. The roads that actually lead directly to Pullen's Gardens are also highlighted. So Penton Place and Amelia Street are marked as important there. But we're still missing some other important context around the immediate vicinity of Pullen's Gardens. The cross streets that abut either end of Pullen's Gardens, those are not pulled out yet. So the next step that the algorithm does is it does a very localized search around the immediate vicinity of Pullen's Gardens and starts to look for signals that might be relevant to highlight on the map for Pullen's Gardens. And what that ends up pulling out are these two smaller roads that are not really that relevant for driving directions or walking directions from further away coming down here, but they are really relevant as contextual information. You know, when I talk about Pullen's Gardens, I'm going to say, oh yeah, it's on Amelia Street between Isle Yard and Crampton Street. And that's what this ends up allowing us to pull out. So you put all of this together, and you have these set of roads that you might want to highlight. So now you have the base signals that you want to use to create the map that Jonah showed earlier. Again, as he mentioned, you don't really want to just show a map as desaturated as this. You end up losing a lot of other contextual information that may be useful to some users, even though it's not the most useful information for this place. So how do you go about doing that? Let's start again with the base map and just a marker. That's all we have. And now let's start pulling in the signals that we captured in the previous slide. So the first step that the algorithm does is it runs a restyling filter on this base map. For every single road that we picked out as an important road that we marked as blue in that previous slide, we will increase the intensity of the color and the strokes used for that road. So I'm going to sort of flip back and forth between these a couple of times so you can see it more clearly. Here's what the base map looks like. Here's what the new map looks like. Base map and new map. And what you see is the roads that are important have now become whiter, and the strokes have become darker and stronger. So they get pulled out a little bit, but not so much as to be in your face. And the other thing you notice is all the other roads get dimmed out a little bit. Those other roads are not as relevant. You don't want to take them off the map because somebody else might care about them, but you want to leave them on the map, but reduce their intensity so that you can actually pull out the roads that matter. So again, I'm just one last time going to show the previous thing and the new one. And so this is step one. You restyle everything. But notice that these streets that we thought were really relevant, like Crampton Street and Amelia Street, are still not labeled on the map. So that's the next step that the algorithm does, is it runs a relabeling pass in real time as you've just clicked on this location, and that gives you this. So now Amelia Street is labeled, Crampton Street is labeled, and we've made the label for Pullen's Gardens a little bit bolder and stronger because that is obviously the most important label here. Again, I'll flip back and forth once or twice. Here's what it looked like, and here's what the new thing looks like. The other thing that the map does is it takes away some of the labels on the less relevant streets. So minor side streets that might have been labeled earlier because there was enough space on the map to label them will take away some of those labels because those labels don't matter nearly as much anymore. But the labels of the streets that are nearby that we've identified as important streets, they're really important, so we'll label them more strongly. So this, sort of in a nutshell, is what the core set of algorithms that we use to figure out how to create a map that is truly about Pullen's Gardens. And we take advantage of the immense amount of computing power that we have at our disposal in Google's data centers to be able to run this algorithm every single second for every single user for every single task that they perform. The next thing we're going to talk about, I'm going to hand it back to Jonah, is to talk a little bit more about how we explore the world around us, around Pullen's Gardens or one of the other places that you might want to search on the map.
All right, thanks, Yatin. So when I first joined Google, I was living in London, and then I went and joined the Zurich office. And so I packed up my bags and went and traveled there. And I was living in Zurich, and that was all very exciting. And every Christmas, I would come back and I would visit my family. And my grandma at the time, she was getting quite old, and she wasn't really able to travel anymore. But she really wanted to know what it was like nearby where I lived. And she'd never been to Switzerland either. So this is a picture of Street View, and this is my house in Zurich. And the amazing thing was, from our living room or our kitchen inside in London, I was able to go use Google Maps, and we were able to fly to street level and go and explore the area around where I lived. And we called this going for a drive. And this was incredible because it gave her the ability to travel to Switzerland and actually see this area where I lived. Now, my grandma's no longer with us, unfortunately, but if I had the ability to kind of fast forward and show her what we've done today, I think I'd be really proud to show her what we've done, because not only do we have this immersive street view, we also have this incredible Earth inside the browser, which lets you feel as if you're flying all over the city in a helicopter. And we also have these amazingly immersive 3D tours. And this is actually a photo that I took of the main river in Zurich. And the 3D tours are a really interesting part of this, which have a very difficult engineering challenges associated with them. And we wanted to make sure that this wasn't a horrible, overwhelming, enormous slideshow. And we wanted to make sure that it was also more immersive and more engaging than just flipping through one photo after the other. So we used a lot of techniques from cinematography to make sure that we picked the right photos and transitioned nicely between them. Now, again, as with that napkin map, this might be a fairly easy task for a human to do if they were to do it one by one by one. But if you're going to generate, using an algorithm, a great 3D tour for thousands and thousands of places all over the world, this is a pretty challenging task. So I'm going to hand back to Yatin to explain how he went about doing this.
Thanks, Jonah. So before I go delve into the technical details of, sorry, the previous slide. Before I go into the technical details of how we build these 3D tours, let's take a look at a 3D tour in the new Google Maps. What this is a tour of the Notre Cathedral in Paris, which is one of my favorite cities in the world. And it's showing you many different facades of the cathedral. It shows you a lot of detail work on some of the most interesting aspects of the cathedral, and then zooms out and rotates around to give you a final other view of the cathedral. Thank you. So how did we go about building this 3D tour and other 3D tours like it? Again, one of the big themes around how we went about building a lot of the technologies behind the new Google Maps is the immense amount of information that Google has access to. So for 3D photo tours, the core set of information that we started to look at is the thousands upon thousands of photos that users like you and I and Jonah have uploaded to Google for public consumption by everyone else. So this might include photos that you might have uploaded to Google+ that you've explicitly marked as shareable with the entire world. Photos that users might have uploaded to the Panoramio photo sharing site, and any other similar site within the Google ecosystem. So what this is showing you is just a sliver of the tens of thousands of photos that we have of the Notre Dame Cathedral. There's a whole bunch of these photos, and what we want to now do is figure out how do you take all of these photos and go from them and create a single photo tour out of it. So the first step of the entire process involves running a long series of complex computer vision algorithms that analyze this entire collection of photos for the Notre Dame and try to figure out exactly where that photo was taken in the real world and where in the real world every single pixel in every one of these photos corresponds to. So for each pixel in every photo, we know exactly which other pixel in every other photo that particular one might correspond to. And what that allows us to build is a fairly detailed three-dimensional model of the Notre Dame Cathedral. And I'll show you what such a model would look like. So what you're seeing here is what we call a 3D point cloud. It's a whole bunch of dots thrown into three-dimensional space, and then I've just captured a screenshot of that. And what each of these dots represents is one point that across the entire set of photos that we identified. And for each of these points identifies a point that was matched in a set of pixels across all of these photos. And you can see, although the 3D point cloud isn't complete, you can clearly see that this is a representation of the Notre Dame Cathedral. So what do we do once we have this 3D point cloud? The next step is, again, as I said earlier, we have on the order of tens of thousands of photos of the Notre Dame. If I were to show you all of those, that would look like a tour of your poor cousin's trip that he took, and you don't want to really sit through those 10,000 photos. So what we really want to pull out is a handful of photos that really represent, that bring out the essence of what the Notre Dame looks like. So we go we look at, one thing we want to capture is what does the Notre Dame look like in context? What does it look like in the surroundings where it's physically located? So that's one photo, zoomed out far enough where you can see the entire cathedral. You see it's right on the main river that runs through Paris. You want another one that really brings out what the cathedral is about. So this is a front facade photo of the cathedral. Each of these photos that we're picking, we also rank them based on how popular they are. How many users have looked at that photo, how many people like that photo, and so on. Here's the third photo. This really gives you a sense of detail that that represents the cathedral. Again, this is the central arch in the front facade of the cathedral. And what this is capturing is one of the main aspects of the cathedral that lots and lots of users are taking pictures of. Another thing you might want to capture is yet another perspective on what the cathedral looks like. So you might want something that captures a photo from, say, the right-hand side, and then yet another one that shows you the right-hand side facade of the cathedral, as we saw at the end of the tour. So this gives you somewhat of a sense of what the cathedral would look like from various angles. But that's not quite enough to really give you sort of an immersive sense of what the cathedral feels like if you were to visit that. So another thing we look for is really picturesque photos of the cathedral. And there's a number of signals that we can take into account when identifying photos that are considered picturesque. What this shows you is a very beautiful nighttime view of the cathedral. The cathedral's beautifully lit up and really gives you a sense of a very different way of looking at the cathedral. What might be examples of photos that you don't want to choose for your photo tour? Here's a couple. Now, this photo on the left, it's a really beautiful photo of a bunch of flowers. If you want to look at the cathedral, it's not nearly as representative of the cathedral. You can see bits and pieces of the cathedral on the top left corner, but they're kind of blurry and not really in focus. It's not a very representative photo. And then that other photo on the right, it's a wonderful family enjoying a great vacation in Paris. Not something that's representative to this entire audience. So those are a few things that we look for when we try to figure out which photos may not be good photos as canonical photos. So now we have all of these photos. What those green dots around the 3D-point cloud are showing is the specific camera position where that photo was taken from. And this is, again, something we can infer as we're building the 3D point cloud. So now we have a set of photos, and we know where those photos were taken from. What's the next step? Well, what Jonah mentioned earlier when he was giving you a very high-level overview of these photo tours is we want to take into account how cinematographers have really thought about how to navigate through a scene, create a camera motion model that really sort of reflects that and gives you a very smooth, fluid motion throughout the entire scene. So we take all of the canonical photos and arrange them such that you can create a path from camera position to camera position that feels very fluid and natural. And that's what this reflects, is we're going from the photo on the bottom right all the way around in clockwise direction. Let's take all of those and arrange them in sequence now. So that's what this would look like. So if you only took this information and started to create a slideshow, a 3D slideshow out of this, you would end up with a lot of artifacts. Going from the photo on the far left to that next photo, nighttime photo of the cathedral, you're going to see a lot of stretching if you try to just warp one photo into the next photo. So what you want to do now is identify a few interstitial frames that you can use to really create a smooth transition effect. Now, what you know here is the set of photos that you really want to linger the camera on, and then you just want to identify a few additional photos that you can breeze through without spending a lot of time. And you know the general camera path that your tour is going to take. So what you can now do is go back to your data set of tens of thousands of photos and start looking for a few other photos that match that general camera path. And that gives you something like this. Those red dots are the new camera positions that we added, where we found a few interstitial frames, and we added those frames to this entire sequence. Now, these interstitial frames, they don't need to be terribly high quality. You can use fairly low resolution photos and still be okay, because they're merely being used as filler material as you're going from one photo that you're going to linger the camera on to the next photo. So you have a lot of flexibility in being able to identify photos that really give you a very nice, smooth transition. You put all of this together, and that ends up giving you a 3D tour of the Notre Dame. We can do this not just for the Notre Dame, but for any other landmark around the world. And we can do it not just for landmarks. So let's go back to the center of Zurich, where Jonah used to live, and see a photo tour of the center of Zurich. And this is showing you a tour around the Limmat River in the center of Zurich. And it gives you sort of a nice 360-degree view of the heart of Zurich. So I hope sort of this was a very quick overview, but I hope you were able to get somewhat of a sense of what the underlying techniques are that go into building these 3D photo tours. So before I wrap up, I just want to sort of go back and summarize what the two main things that we covered. The first one was, how do you build a map of a place every single time for every single user? We use a lot of information that Google has access to about how places are structured, how people navigate to get to those places, to build these maps. And the second is, once you've figured out how to get somewhere, you want to really get to know that place better. And so we have a number of different techniques that we use to really give you a rich, immersive feeling for what these places look like in the real world. Now, both of these techniques that I described, they're very much in their infancy today. We think we've taken a very big leap forward with the new Google Maps from what online mapping can do these days, but we still have a long way to go forward. And we hope that you enjoy what we've shown you so far. We believe there's a lot of still very hard, difficult computer science problems to solve that will keep making these experiences better and better over time. And we hope you'll continue on the journey with us as we try to make a mapping experience that is truly unique, truly for you, and truly about every single task that you do every single day. With that, I think we would like to open it up for any questions you might have. There's a pair of microphones here that you can walk up to, and we'll be happy to take any kinds of questions and not drop the mic.
I wonder, when do you think we might see the new personalized maps showing up on mobile, on Android and iOS?
So the thing that we talked about during the keynote on Wednesday was that we kind of came up with this vision of how the future of Google Maps would be as we're moving forward. So the thing that we announced on desktop on Wednesday was the desktop incarnation of where we're heading towards in that future. And I think that as time progresses, you're going to generally see this kind of experience be mirrored across all different devices, because we want everyone to have a very seamless experience across all devices. So this is the desktop is a preview.
So what we have now is the desktop version. We will continue to work on improving our look and feel of maps and unifying them across all of our platforms. Yes, sir.
In terms of how the new mapping system relates to the old mapping system, how much extra does it cost you in terms of compute power to do this? And is there any saving in terms of data flow from cutting down these maps?
I can't go into a lot of specifics on exactly what is different, but we take advantage of a lot of different levels of both simplification and easier and better serving systems to allow us to build these maps. So Obviously, creating a map on the fly for every single user, every single task that they perform is going to take more computing power. But we try to be fairly efficient about how we go about doing it so it doesn't become an overwhelming thing. Even for Google, we do want to be conscious about not using a lot of compute power. So we try to be fairly efficient there.
And there's a distinction between, of course, client-side computing power and the server-side computing power as well. So in terms of the download that you get to your local machine, the amount of data we send should be, I mean, for the basic map case, it should be similar or even less because it's more efficient. We're sending vector maps.
That is true. Because we send vector data down to the client, now the total amount of data that we send to the client is much lower. And we can take advantage of all of the compute power that each of you have to draw the map for us. So that becomes a shared responsibility where we do all the hard work in our infrastructure and then send very simple information down to the client and allow the client to render stuff.
Hi. I think one of the most interesting things was the way you guys did the WebGL rendering in the browser, and reading the media coverage about this, doesn't seem like anybody noticed that. I was wondering if you could talk a little bit about the challenges of doing that. Specifically, I'm interested in how you're able to share that code across all the different platforms you're supporting, including Android and iOS.
So the WebGL stuff that we worked on is primarily for desktop. The vector maps that our mobile platforms use a native variant of it. We do try to share a lot of themes across all of these platforms, so we have the same look and feel for the maps no matter which platform you're browsing on. So when it comes to a bunch of the 3D rendering, we share a number of the low-level shader code that each of these platforms rely on. But then WebGL, iOS, and Android have their own variants of implementation on top of that that are native to the platforms that we work on.
So what you show here is very cool, but you said it's still in the early stage. What I'm curious to know is what are the major areas you see that needs to be enhanced?
So be enhanced? Sure. So there is a lot of improvement we can make to our product every single time, right? We're very proud and very happy about how far we've come, but there's so much more that can be done. A map that is truly about you continues to evolve. As I evolve, as you evolve, we're going to continue to, as what we expect out of online maps evolves, we're going to continue to want to improve it. So we see this sort of as just one step forward in what people will come to expect out of online maps. As people get used to this new way of exploring the world, there will be newer and newer things that we'll want to do with our maps. There's a number of interesting ideas that hopefully we'll be able to share with the world as we start building those and creating an even richer experience.
Yeah, I think it's a really interesting challenge because the two things that we showed today are kind of trying to algorithmically generate something that a talented human would be able to do, and that's really tough, right? So I feel like, the fact that we've got as far as we have with the 3D tour now is amazing, but that's still, if it were a human doing it, it would be a kind of a mediocre 3D tour, right? And wouldn't it be amazing if the 3D tour could be incredible, like one of the top directors has done it? And very similar with the hand-drawn maps. So I think it's amazing how far we've come, but there's still a long way we can go with that.
Yep.
So do you have like a fixed database of landmarks for which you generate the 3D tours, or is it just possible for anyone to ask for a 3D tour of any place essentially on the planet?
It varies. So we can create a 3D tour of any place for which we have a large number of photos. You do require a reasonable number of photos. If you only have 5 to 10 photos, you can't really extract a rich enough 3D structure out of that. But once you have enough photos of a place, then it's pretty easy to create a 3D tour of that. Now, obviously, we don't have anything in our current product that allows you to just create a 3D tour of something that you generate. But so what we take into account are signals like what are places that are going to be interesting to our users, what are the most relevant places for, say, any given city around the world, and to try to take those signals into account when we figure out where we want to publish these 3D tours. But the basic concept, if you took 1,000 photos of your house you would be able to create a 3D tour of your house.
If everyone in this room went outside and took a photo of the Moscone Center, we'd probably have a Moscone Center tour pretty soon.
So do you choose these places like manually, or is there some algorithm that chooses those places?
No, we don't choose it manually. It's algorithmic. There's many tours around the world. Yeah, there's a whole bunch of algorithms and a number of signals that go into it. It's basically, at a very high level, it's driven by popularity. Right? The most popular places we want to create tours for.
I guess somewhat related to the previous question, when you're looking at all these thousands of photos, is there some level of manual filtering that you do with the photos as well, or is it purely algorithmic?
The first pass is purely algorithmic. We do perform some manual moderation to verify that the algorithms work well. That will go down over time as we gain more confidence and as we gain more signals to feed into our algorithms.
I think there's quite a lot of manual work that goes even before this as well, right? Because the photos that are selected are the popular ones from Panoramio or from Picasso, and something being popular is obviously a very, very human thing, which is people like it, they share it, all of that kind of thing. So there's very much a human element in the beginning about the popularity, and then the kind of the algorithm takes over from there.
And that manual work is taking advantage of the immense human computing power of the entire world.
Yeah, just to touch back on the idea that if I was to take 1,000 photos of my house, a 3D tour could be created around it. Is that a service that you might want to offer to an amateurs like me, that I could plug a bunch of photos in and it would do that for me? Or
it sounds like a great idea. We'll have to take it into account. Any more questions? Yeah, I don't think there's anything else here. But
Lucky that didn't happen in the keynote.
Oh, right. This thing has the old password.
All right. It looks like that's all the questions then. So thank you everyone for coming. Yeah.